Yeah, so hacked together a quick project that is implementing guardrails, but at the tool layer, not the input-output layer. The reason for that being is many of the hyperscalers like Azure, AWS, and such, they're built in guardrails along with the incumbent guardrails. They are built for chatbots, not agentic AI systems. The big differentiator is agentic AI systems are connected to tools. Tools are usually just APIs of enterprise offerings. This is the lethal trifecta problem created by Simon Willison in like the Bay Area. Basically, AI agents have this fatal flaw where they can have access to private data, they can externally communicate, and they also just carry out untrusted actions. It's a problem in enterprise for obvious reasons, like any Copilot agent, Bedrock agent, and such. They're all susceptible to this. Um, Most people are implementing guardrails at the AI layer, but I thought that it makes more sense to implement it at the tool layer and treat it as a heuristics problem to infer patterns on what is indicative of an indirect prompt injection as opposed to just reading the tokens at input and output, at which point it's already too late because the exfiltration has happened at the tool layer. Um, yeah, so the idea is like coming from like treating it as like a heuristics problem. You're able to like create policies maybe that learn from tool behavior and they're adaptive in some sense, and they're able to pick up patterns that are like indicative of some offhand behavior. This is kind of a take on like how we can maybe implement it. Is this is like coming from taint analysis in API security, where in which when you have many APIs connected together, some are sources and some are sinks, and when they're connected in a particular order, it's bad. Kind of applies to tools too, where in which the exploit, how this applies to NLWeb is, so I made a quick Shopify website, put a prompt injection attack here. You can't see it, but NLWeb is an MCP by itself. So when a cursor talks to this website, this is like invoking GitHub MCP to grab secrets and then exfiltrating it via it opens a GitHub pull request and puts the secret inside, so it gets exfiltrated. And the agents, the MCP client just doesn't. So you would have seen it here if you treated it as a taint analysis problem, because if you just map all your MCP tools connected, you can see that there's a source sync combination here that is indicative of a bad pattern. So potentially, like maybe like a SecOps person could come in here and see there's a potential taint analysis of tools, go up into the policies, and then create like a runtime policy going like, yeah, let's block that taint analysis scenario. Let's create some pre-tool, post-tool call here, and let's maybe deploy it. So trying to build up on how security is being done in the past, I guess, for APIs and move them on to like the tool layer for like indirect prompt injection attacks. Yeah, that's everything.
Time for any questions? Judges? I mean, first of all, love this problem space. I've been pounding the table on this over the past few weeks of like, there's a real big problem, and it's cool to see you tackling it. What's your background? Do you have a background in security? Or?
Yeah, security space,
yeah.
de-anonymization algorithms. Yeah.
Clever, really, really good.
Yeah.
So you said you added a layer in the MCP, right?
Yeah.
In MCP layer. And how like MCP layer, if I know like on high level idea, it's just like a fake copy. So how you're checking something?
It'd be like a runtime proxy. So MCP is just one of the protocols. It could be A2A, it could be just Open API spec. Whatever is your tool calling layer.
Yeah, so if I say it's just Open API, and then like how you're like securing.
It's just a runtime proxy. So it would sit between your LLM and whatever protocol you're using to talk to your APIs.
What do you think the future of this is? Do you think there's going to be some kind of like standardization of MCP connection?
That depends on there's like a MCP advisory committee, I believe. I think hyperscalers are part of that, so they all are standardizing onto it. There is like uptake in this protocol, but MCP outside, the problem that I mentioned is inherent in any protocol. It's just an inherent flaws of how that is like the reality of semi-autonomous systems or autonomous systems is when you trust in the system, they can carry actions like that.